All right, so this is drill number 4. As usual, the unfilled drill and the filled sheet will be in the description. Starting with number 8, which describes the visible emission spectrum of hydrogen. Well, we're going to keep looking at these emission lines, starting at n equals 1, 2, 3, 4, 5, 6, until they all converge to infinity. So on this convergence, we're going to have convergence over here at this top, where when we drop down, we are producing a very high energy. And so that's going to represent UV radiation. However, this is describing the visible emission spectrum of hydrogen. So we're actually going to be talking about all of them converging to n equals 2, representing the Balmer series. So it's definitely not regularly spaced lines. We know that for a fact because they converge. They're not converging at a longer wavelength. They're not converging at lower energy. These two are pretty much the same, and it can only be one answer. They're converging at higher frequency. As we go higher up, we have higher frequency. All right. What is the order of increasing energy of the orbitals within a single energy level? Well, this is just straight up the general way of SPDF. If we look at our periodic table and we go across, S and P are around the same, D is lower, and F is even lower. And as we fill them up, filling up these orbitals, they are higher energy as we go out. So that is B. What is the configuration for the electron configuration of cobalt 3+? So going to our periodic table, let's start at cobalt. 3+ means we're losing 3 electrons. So it's going to be the configuration of 1, 2, 3. Chromium, which actually, because when we look at chromium, we have D1, D2, D3, D4. The d orbitals like to actually represent 5. So we're going to steal an s orbital to get up there. So it's going to be 4s13d5. 4s13d5. There we go. Draw and label the energy level diagram for the hydrogen atom. In your diagram, show how the series of lines in the ultraviolet and visible regions are produced, clearly labeling each series. All right, we did this one in class, but we'll just start it over again. N equals 1, 2, 3, 4, 5, 6, 7, 8. N equals 2, N equals 3, N equals 4, N equals infinity as they converge. So our UV is going to be any drop to the N equals 1. And this is going to be the Lyman series. And then our visible is going to be any drop to the N equals 2. It's going to be our Balmer series. All right.